All right, well, welcome everyone. Thanks for joining us today. I don't think I need a microphone. Hopefully everyone can hear me. Okay. My name is Mike. I've been with Oracle. It's my 18th and a half year here. I spent I like to say I'm not a DBA and I wasn't acquired. So I'm a little bit different of a background. I joined Oracle to help build their identity and access management practice when Oracle was doing a lot of acquisitions in the application space and middleware space. And spent the first half of my career doing all things cybersecurity, identity and access management, and now have been with Oracle Cloud, OCI, since 2017 or so. I currently lead a team of field engineers that support our North American commercial customers as they're evaluating Oracle Cloud and also migrating workloads into Oracle Cloud using Oracle Cloud, et cetera. So today we're going to talk a little bit about what is this thing called OCI, or Oracle Cloud Infrastructure? It's been interesting being here this morning. It's a little microcosm of what I experience out in the field and with customers all the time. I heard Oracle, they have a cloud? No one's using that, right? And then I also heard, oh, Oracle Cloud, that's the place for database workloads in the cloud. And I also heard Oracle Cloud, great, KVM based, we're using it, a lot of great experience with it so far. And I think that actually encapsulates what I hear a lot from customers. Many folks are still not aware of what Oracle has done with Oracle Cloud Infrastructure since 2016. So I'm going to talk a little bit about that, keep it very technical, ask questions, keep it conversational. Oracle is, an engineering company still. So I think what makes us a little bit different than some of the other clouds out there is our focus is still just enterprise software. And we have a 47-year history of delivering high-class enterprise software. And when we approach OCI, or Generation 2 Cloud, the goal was, how do we create a cloud for all workloads, for mission-critical workloads? So we don't have a lot of distractions at Oracle. We don't have trucks driving around and delivering stuff to your houses. Our focus is only cloud and enterprise software. So I want to talk a little bit about what are some of the engineering things that we did very differently in Gen 2 Cloud that make it a little bit unique to other experiences that our customers have had with other clouds and infrastructure. So if I go back to 2016, so what we did, and it's been great being here and seeing kind of the transformations that Oracle has gone through when we acquired Sun, when we started developing more applications. It's been cool to be part of this, and cloud is just that recent transformation that Oracle has undertaken as well. So we went out and we hired aggressively in a number of different companies. So we went and hired a bunch of folks from AWS, and we hired a bunch of folks from Azure, and we brought them, and then eventually GCP, but primarily at first it was Azure. We moved our development. Our development was traditionally based in Redwood Shores. We moved our development to Seattle. And we brought in architects and engineers and said, if you're going to start over and build a new cloud, knowing what you know, developing Gen 1 cloud, what would you do differently? And the first thing that we started to do was really re-engineer the core of Oracle Cloud Infrastructure. And I'll just point out a couple of things here, and we're going to get into more details as we go throughout. But this notion of off-box virtualization. So the first thing that we wanted to do was we wanted to really separate the hypervisor from the host server. At its core, OCI is a bare metal cloud, meaning you can get just bare metal services delivered to you. You can roll your own hypervisors on top of that, and those are kind of first-class entities inside OCI. So at its core, a bare metal cloud, and we've separated the hypervisor from the actual physical host. So what that does is it gives you things like better performance, better security, better manageability. And we were able to actually put SLAs in those things. So because we've removed that hypervisor tax of managing the hypervisor layer on top of the bare metal server, what I can do now is I can actually guarantee CPU bandwidth to you. In other clouds, what you saw was a provisioning of threads. So you're getting a thread provision to you when you get a VM. We can provision you an actual core, and we can guarantee that core. We can guarantee network bandwidth to you because we've off-boxed the virtualized network as well. We've created a layer 3 virtual network that sits outside of the physical server. I'm going to get into some diagrams. We'll see how this all looks like as well. But it's really this notion of like, let's take all of the management stuff of the hypervisor out of the actual host and put it on dedicated hardware so you get better security, better manageability, better performance. That's what Offbox is all about. We spent a lot of time looking at networking and creating a closed-based network that's non-blocking, non-oversubscribed, so we can guarantee throughput. This greatly reduced the networking costs for our customers as well. We did some really cool things with Flex architecture. So what this means here is I have a customer that I'm working with right now that needs a core CPU, a couple of cores actually, and a terabyte of memory. We're able to flex those things up and down when you select a VM. So if you have very specific requirements for memory versus CPU versus IOPS, you can flex all of that stuff up. So instead of trying to t-shirt size into specific VM shapes where you end up with a list of like all of these VM shapes that you have to try to fit into, we have just a VM family. Here's your AMD family or your Intel family, and you're going to flex up and down what you want from an infrastructure perspective. I skipped over this, maximum computing density. The important thing here, if you look at this, we can deliver a single cloud region in only 12 racks. So you're going to see very soon where we are deployed across the globe, which I think is a big surprise to our customers as well. Part of that is because, again, we were, I say a fast follower. You can say we were late to cloud, however you want to term it. We have those advantages of coming after Gen 1 cloud and being able to re-architect and do things a little bit differently. And that gave us the ability to really optimize how we do our deployments. 12 racks to deliver an entire cloud is a big deal. That means we can accelerate and get into regions that folks can't get into very quickly at a very cost of price performance point. And I won't spend too much time talking about pricing. The pricing is just really a result of all of the architectural changes that we've done. There's, I think, a misconception, that is Oracle buying this cloud business? And the truth is, no. I mean, we just have better metrics and better commercials because of the way that we're architected. This part is always a little surprising to folks, is just where have we gone since 2016? You can see we're deployed all over the globe. We have currently 81 regions. So 50 of those are public cloud regions, and then you see that 31 dedicated or alloy regions. So what these are is if as a customer, you say, I would like a cloud in Concord, Massachusetts, where I'm from. We can deliver a dedicated region in 3 racks to you. So it has every single cloud service that we offer. It's the same subscription-based pricing, but delivered in 3 racks that can run in your data center behind your firewall or in a colo if you'd like. I think when we get into 2025, 2026, we're probably going to see parity between the number of public regions that we have and the number of dedicated cloud regions that we have. The other thing that you'll notice here is that we have a lot of Azure and Google symbols. I remember when Oracle, when we did our annual conference, it used to be called Oracle Open World. And it's now called Cloud World. The reason it was called Open World is you could run the Oracle database anywhere, as like we're talking about here today, and all of the systems that we still support where you can run Oracle database. And that was always the case. Oracle was an open platform where you could run it anywhere. We're really getting back to those roots with Oracle Cloud Infrastructure as well. So the first thing that we've done is we've created these interconnects. So if you're sitting in, let's say, US East, you can connect OCI directly to GCP, directly to Azure, which means you have an ultra low latency bandwidth between those 2 clouds, and also no egress and ingress fees as well. We want to allow people to move their data wherever they want to move it, to use the best of the clouds that they want to use out there, and offer very easy ways for folks to leverage the technologies that are important to them. The next step after interconnect was we actually started moving pieces of our cloud, not all of our cloud, but pieces of our cloud into the other clouds. So for example, you can deploy Oracle Exadata Cloud directly from Azure. You go to your Azure console, you select Oracle Database OCI, and it's provisioning a database Exadata service for you inside Azure. It is OCI. It's managed by our team. It is an Oracle Cloud region that's sitting inside an Azure data center. We're doing the same with GCP. And just this past September, we announced the same intentions with AWS, and we're rolling out those regions now. So dedicated to open source still, and dedicated to multi-cloud architectures. So that's a little bit of what we've been up to from a growth perspective and a region perspective at OCI. Very open platform. There's not a lot of things that are proprietary inside OCI. I'll give kind of my two favorite examples. We use Terraform throughout for all infrastructure provisioning. There are some clouds that have kind of proprietary ways of doing infrastructure as code. We use Terraform. We also use the OpenFN project for our functions. So if you're doing anything serverless, that's all OpenFN inside OCI. We didn't want to recreate any type of management layers or any type of infrastructure as code layers. We wanted to leverage what the market is leveraging. So we're really embracing all the open source stacks from that perspective. Talk a little bit about just services and where we are. There's a plethora of services that we've introduced inside Oracle Cloud Infrastructure. I want to be kind of clear. Another kind of misconception is that, that I mentioned that Oracle is the place where you run Oracle workloads. The majority of things running inside OCI today are cloud native workloads. We do have customers that come in and run Oracle database and Oracle analytics and Oracle applications inside OCI, but most of the workloads running and our largest workloads that run are all cloud native workloads. Think of, for example, like an Uber that moved their entire rideshare application over to OCI. So it's just a Kubernetes workload with streaming. It's network, compute, storage, Kubernetes, streaming services. That's the type of stuff that make up our largest workloads inside OCI. The other piece of that is a lot of GPU model training. The largest large language models have either been or are being trained on OCI currently. Microsoft trains Bing on OCI. So it has become quite the place to come and do model training. And that has everything to do with those architectural differentiators that I talked about earlier, where we're able to very quickly and affordably scale up from 1 GPU to 32,000 GPUs over a very fast RDMA-based network. So you can create these very affordable superclusters to do model training. If you just need a couple of GPUs to do inferencing for models that you've already created, we're a great place to do that too, and can even do kind of fractional GPUs with some great partnerships that we have. But all of the core services that you would need, yes, we have great Oracle database services. We also have all of open source database services. So a lot of customers using Postgres and Redis. So a lot of great things that you can do inside OCI from a database perspective. We do quite a bit with artificial intelligence, machine learning. Yes, we have Gen AI services. Not all AI is Gen AI. I like, it's great that people are now really enthusiastic about AI, but AI has been around for a long time. One of my favorite projects, I've worked with a number of hospital systems that have been using our OCI Vision services to do a lot of radiology type of use cases. So take a bunch of retinal scans, put them into OCI Vision services, do supervised training on top of it, and then be able to do things like diabetic detection on retinal scan images. So some of those classic AI use cases, I think it's actually like one of the biggest benefits of all of the Gen AI hype is that people are getting funding to do regular AI stuff that's been around for 10 years. And they're kind of just putting in these projects and it's like, I'm doing my Gen AI stuff. It's like, nah, that's really document understanding and that's really, vision. But okay, sure, you're doing like great AI now. So we've seen this like great increase in the amount of AI projects that are taking place, and those are always fun to work on. I just very quickly from a deployment perspective, I just wanted to cover that the notion of dedicated regions is starting to really explode. So, if you're thinking about computing at the edge, computing locally, if you have customers or you are a customer that says, public cloud, not for me, but can I leverage some of the benefits? The answer is yes. Like we can deliver a very small footprint private cloud to your on-premises data center. We can deliver it to the edge. We've delivered it to oil rigs and to the Army and naval bases. I mean, there's a lot of great things that we can do with distributed cloud and private cloud architectures. We also, of course, have our GovCloud offerings for if you're doing government work. We have sovereign cloud offerings. So if you need sovereign cloud in the EU, so a lot of great ways that you can deploy the cloud where you need it and where you want it. The other thing I heard today was like, just very quickly, this is my only marketing side, is who's using OCI? OCI is used by a ton of customers today. I know in the space I work with, I have over 5,000 consuming customers that are on OCI today and growing globally. We have a massive footprint as well, from very large organizations here to small startups and folks that are just 10 people companies that are using us to do some cool GPU model training or develop their new application. I do a lot of work with startups. It's some of my most favorite work because everyone's so close to the mission and and to the work that they're doing. So I get really excited about doing those types of projects. But yeah, OCI, great platform used by a lot of our big and small customers out there. Let me pause just to see if there's any questions. I'm going to shift and talk a little bit about some of the core architectural pieces across the different tiers of compute and networking and some of the services we looked at. But any questions, comments so far? Yes.
A few slides back, you were showing the different areas that you could connect through, and they were low latency.
Yeah, let me bring our little map up here.
Yeah.
Yep.
So, and were there interconnecting through those? Do you call them hubs or what?
So they're essentially data centers. So when you're like, if you take Ashburn, Virginia, Ashburn, every single cloud is in Ashburn, Virginia. And what we have is, where Oracle has their, what we call availability domains. Our availability domains have dedicated fiber to Azure's availability domains and to Google's availability domains. So that gives us that dedicated fiber means you're not going out into like internet and coming back in through their channel. We're going back channel,
Right.
like
So
dedicated fiber.
This becomes low cost, a little bit latency to take advantage of those.
Exactly right. So yeah, so directly from Oracle directly to Azure. And then so the way networking, and this is kind of important for you all as you're thinking about, I have my OpenVMS and I'm putting it out there and I want to start creating my clusters of systems. The way Oracle Cloud works is, so you have a region like Ashburn. That region will have what we call availability domains. Availability domains are physical buildings, they're data centers. So in Ashburn, we have 3 availability domains. The availability domains are actually collections of physical buildings. There's actually about 8 different buildings, I believe now in Ashburn and growing. And those are lumped into availability domains. So as you deploy something, you can say, hey, as you're in your console, you'd say like, all right, I'm going to deploy this Kubernetes cluster and it's going to provision these VM nodes, but I want to balance them between AD1 and AD2. So right. In case AD1 goes down, you still got stuff in AD2. Now we have more resiliency than just that. Even within a given availability domain, you can pick what we call fault domains, which are different hardware couplings. So think of like I had outages happen. Like I'm not going to throw stones in glass houses. Outages are going to happen. We had a recent outage that happened, or let me call it a service interruption that happened. It wasn't like a region went down, but we had a service interruption that happened in Phoenix 2 weeks ago. What was the cause of it? There was a top of rack switch that went down and 7 servers were affected. I can tell you the tale of 2 customers. There was one customer that had 0 impact from that because they were deployed across fault domains and availability domains. And there was a customer that was down because they were deployed in one availability domain and one fault domain. And when that top of rack switch was hit, it affected, they happened to be on those servers, so they were impacted and they couldn't access block storage. But we give you the tools and the mechanisms to be able to deploy. So even like if you have, we had a power outage or an HVAC problem 2 summers ago, and it affected one floor of one building. That's one fault domain. If you're deployed across multiple fault domains, you would load balance just fine and wouldn't be affected. So this is why we have the guarantees of availability and manageability. And if something does happen, we stand by those with financial paybacks that we give our customers if we don't meet those availability requirements. Sure. Any other questions? Let me move ahead and talk a little bit about some of these differentiators. We'll start with compute. So I've talked a little bit about this, but kind of first generation to second generation cloud, the big difference, and now other clouds are starting to do this type of architecture, but they have to retrofit it to their existing global environments. This is where we started from scratch. So every single environment we roll out is like this, where we have this off-box network virtualization, and we're off-boxing all of that hypervisor management as well. So what this does, like I mentioned, is it also prevents things like if you do a VM escape attack up here and you compromise the hypervisor, you now have access to the network and you can start actually traversing hosts and really proliferating that attack out. That you can't do that here where there's no access to the actual virtualized network. So this goes back to we acquired Sun manufactured hardware. We continue to leverage all of that engineering muscle in OCI. We use it for how we construct things like Exadata and compute cloud at customer, but it's also how we construct our cloud as well. So we created smart NICs. So smart NICs actually are NICs that sit at the host that sit top of rack and are isolated from the physical host, and they do all of the network processing for the physical host. So there's no NIC that's sitting on this physical host that's doing any network IOPS at all. So that's giving you that layer 3 virtualized network. That's making sure that we can not guarantee network performance. We're not oversubscribing the network at all, and we also can do CPU or core-based provisioning rather than thread-based provisioning from a VMware standpoint, so that you are kind of guaranteed the CPU bandwidth and IOPS that you're getting from those servers. So it's just a radically different way than traditionally the other clouds grew up in. And it was simply because the other clouds inherited architectural decisions of why they were created. AWS was from e-commerce, Azure was from Bing, GCP from Googleplex. So you're kind of inheriting those design decisions of clouds that were doing other things and then turned into infrastructure as a service, solutions. And they're great solutions, and they've done a lot to revolutionize the industry, but they had some inherent architectural flaws in them that, because we were a fast follower, we were able to correct. So this just covers, some of the benefits that I've already talked about, but really it's, some of the core pieces of just being able to get the most out of the physical server as well. I will say, again, it is a bare metal cloud. So if you don't want this here and you just want, get rid of all of this top layer and you just want a physical server deployed to you, you can choose to have a bare metal server. You can roll your own hypervisor on it. So we have a lot of customers that use their own bare metal services for large HPC jobs, as an example. So they're not using any of our virtualization. If you are using our virtualization, as we were talking about, that is a KVM based virtual layer. We do all of the management, of course. So you're just choosing, I want this AMD processor or this AMD family with 2 CPUs and 10 terabytes of memory, and I need this much IOPS and attach it to this type of block storage, and I need a terabyte of it. So you're kind of picking what you want for your shape, and then we're provisioning that to you. We're managing all of the hypervisor entirely. Did not know there was that very cool transition there. What do you know? That was crazy. So a variety of different families. I'm starting to see a lot with Ampere. So if there's an opportunity to deploy on A1 and A2s, we are seeing a lot of that architecture starting to roll out now. From as you're rolling out your solutions, there's a variety of ways to make this very effective from both like a design and high availability and resiliency, but also from a cost perspective. So of course you have on demand. I'd say the majority of our customers are just using on-demand VMs. You pick what you want when you want it, and we provision it. And that's also how, if you have a Kubernetes cluster that's auto scaling, it will start to auto scale nodes up on demand and just launch those VMs for you. We do let you do capacity reservations, but that is, I do not have a lot of customers that use it. They're widely used in other clouds. It is not it's not a big thing that we have to do inside OCI. Primarily, it's used for GPU when you need large, like supercluster GPU infrastructures. We do a lot of capacity reservations there, but not typical just VM computes. And then we offer kind of preemptible and burstable. Preemptible are great for development environments where you can, like, if you're not using it, it will go away. And you're paying like a fraction of the cost that you would pay for just getting an on-demand OCPU. And burstable, where you can also pay like a fraction of the amount of that OCPU, and it will burst up to 3 times that capacity as you need when your workloads start coming in. So a lot of different ways to kind of flex the architecture so that you're just paying for what you're using inside OCI. How you can deploy. So as I mentioned, it's a bare metal cloud to begin with. And then you can roll out virtual machines. You can deploy your own Kubernetes environments if you'd like. I do have customers that roll their own K8 environments. We, of course, support rolling out containers. We have a managed Kubernetes environment. So if you don't want to manage all of the Kubernetes infrastructure yourself, we have a great managed Oracle Kubernetes container environment that supports both managed and serverless nodes. And then we have our functions, and that's, as I mentioned, we use the OpenVMS project. So if you want to go full serverless compute, we have functions available for you to consume. A variety of different families. I'm not going to get into all the details here, but just wanted to include it so you would see it as you take away the presentation. But there's a lot of, and we continue to grow this. I think we're already testing out our E6 as an example from AMD. Depend, a large variety of what you want to use here from Intel, AMD, and Ampere, and obviously we have a deep partnership with NVIDIA too from a GPU perspective. They're our big partner for all things GPU. I wanted to quickly cover just VMware. We do support VMware, and we do it in a way that's a little bit different than some others out there. Because we are a bare metal cloud at our core, you can bring an entire VMware environment over as is. So you could literally take your on-premises VMware estate, move it into OCI, and manage it just like you were doing on-premises, including all of the VMware ecosystem and tools that you are using on-premises. And then it's connected and works with everything we have in the cloud. So this environment would work with other VMs or functions or GPUs. It's not kind of isolated in its own island. It's a first-class citizen part of Oracle Cloud Infrastructure. We also have, not to get into a whole Broadcom thing, but we have licensing already established with Broadcom that's kind of locked in. So we have customers that are kind of moving in, taking advantage of that, given what's happening. But I have a lot of customers that are just taking their on-premises VMware environments and migrating directly into KVM inside OCI as well, and just saying goodbye to VMware. So a lot of different options that you can do there. Full transition to just our Kubernetes environment. I think Kubernetes for me, as I mentioned, it's a wonderful way to deploy your workloads for a maximum high availability and the ability to scale on demand. So you could have, OpenVMS running inside virtualized nodes and managed inside an OKE environment and scale up and scale down as you need based on traffic. It's just a wonderful way to manage these large infrastructure environments. Most of my cloud native customers are all using either a managed Kubernetes environment or rolling out their own K8 environment. From a networking perspective, any questions just on compute differentiators? From a networking perspective, so, a couple of key things to talk here. I talked about off-box network virtualization, really important to how we're able to provide that low latency, close space network that's not oversubscribed. RDMA, cluster networking. So this was kind of really important for how we managed Oracle and Oracle RAC. It allowed us to do cluster-based database networking inside OCI. RDMA networking also turned out to be very important for how we do large-scale compute networks and GPU networks. So this RDMA networking is what allows us to create these large GPU superclusters and also CPU, large-scale CPU HPC services that our customers use for things like if you're doing Monte Carlo simulation as an example. So the networking continues to be a really important component of OCI. And we also wanted to make sure that it was not an expensive component. So we have tried to zero out any type of networking cost inside OCI. So we don't charge for creating virtual cloud networks or anything like that. There are very, very low egress fees if you're egressing out to the internet. There's no egress if you're going in between, as I was talking about, availability domains in a region. There's no egressing there. So when we look comparatively to like our networking costs versus other networking costs, it's usually, a tenth of the cost or less. So incredibly affordable networking. The way that the networks work inside OCI, it's very similar to creating networks on premises. So you're going to create a virtual cloud network. That virtual cloud network is your private network for your tenancy. We don't have access to anything. Oracle's management all runs on a different substrate network that is totally separate from any type of networking in our customers' tenancies. Inside your tenancy, you create a virtual cloud network, or you can create several virtual cloud networks, in fact. Those virtual cloud networks, then you create subnets in them. The virtual cloud networks are tied to CIDR blocks. So you're going to have a CIDR range of IP addresses that you're going to use. We don't charge you for public IP addresses. We don't charge you for any of the IP addresses that you're using. So you're going to have your public and private IP addresses, your public subnets, your private subnets. You're going to create all of your virtual cloud network just like you would as an on-premises network administrator. So you really kind of have full control over that networking environment. We do partner with Palo Alto for our network firewall. So you have kind of really good network firewalling built in. And then we also have a number of other network security components, which I'll talk about shortly. We've talked a little bit about it, but I guess the key here is, as mentioned, that it doesn't matter if you're doing a bare metal host, if you're running a hypervisor, if you're running Kubernetes, it is all on the same exact network. And I've talked a little bit about how our virtualized layer works, so I won't get too much into the details here. I think the important thing to kind of point out is this maximum of 2 hops between any 2 servers in any region. It lets us guarantee that bandwidth. It lets you do that provisioning across different availability domains and fault domains without having to worry about slowing things down or having to traverse a bunch of different servers. So the way that the network is constructed, you're really free to kind of deploy however you want within a region and not have it affect any type of network performance. I've talked about our, I talked about our all these here. I guess one thing I didn't mention, as our fast connect and site-to-site VPN, the way that you connect to on-premises networks. So you have a couple of different options. So inside Oracle Cloud, if you want to go out and now connect to your backend office, you can do a simple site-to-site VPN, which is going to traverse the public internet, or you can leverage what we call Fast Connect. Fast Connect is just really a port on our side. That's what will give you access to a dedicated line. So let's say you're working with AT&T or Verizon, you can have a dedicated line that goes from OCI directly to your back office on-premises data center. And then there's no egress fees. You just go back and forth through that line, and that's kind of a dedicated bandwidth, dedicated line that you have, not traversing the public internet. So a couple of different ways that you can connect out to your on-premises networks. Any questions from a networking perspective? I'm going to touch a little bit of security here. It's an area that's still very near and dear to my heart, and I spent a lot of time in. The method that we took for OCI security was let's build in as much as we can by default and not charge anything for it. We wanted this to be a very secure place to bring your workloads. So we did things like, all of the data is encrypted at rest and in transit, and all the block storage and all the object storage and the file system storage, and there's no charge or fee for that. We wanted to include built-in identity and access management, so you can easily federate with your identity providers and bring identities that you're using rather than requiring you to build up all of your new users and infrastructure inside Oracle Cloud. So there's a host of security. I'm not going to go through all of them here, but the key is that we've made this all available and included as part of the underpinnings of OCI. There's some cool things too that we've done from an Oracle database perspective. We've made a lot of the the security features that were part of the Oracle database traditionally were licensable options on premises. We got rid of all of that. So if you're using Oracle database and OCI, all the security is built in and included. There's some wonderful solution called Data Safe, which allows you to actually look at the security posture of all your relational databases and make sure that there's no configuration drift and that you don't have privileges that are proliferating out or roles being granted to users that shouldn't have it. We have a security posture management system called CloudGuard that does the same thing for Oracle Cloud Infrastructure to make sure that you don't have the wrong ports opened up or that you're not, having machines starting up that shouldn't be started up. Someone that's trying to, for example, provision something into a public subnet that shouldn't be in a public subnet. We can detect all of that stuff and actually remediate it on the fly to make sure that those things aren't happening. Actually, a lot of the public breaches that have happened in clouds have really not been the fault of the cloud provider. It has been misconfiguration that's done by the end users. So we really wanted to put systems in place that took care of all of that misconfiguration, detected it, remediated it quickly for you, so that you're not having any of those types of breaches. We've gone very big internally on passwordless authentication. So I don't use a password to access anything at Oracle anymore. I use FIDO authentication by just staring at my phone. So we support doing multi-factor authentication, passwordless authentication systems across all of OCI, just to get it as secure as possible as you do your deployments. Just like some of the things I already mentioned, but all of the auditing, CloudGuard, Data Safe, all of these things are free. We work with the Center of Internet Security to publish landing zones. So you can go out to CIS and see your OCI landing zone. We update this frequently. So when you create a new tenancy, you can drop down a landing zone, which creates the right separation of duties and privileges and puts the right gates and guards across all of the different aspects of the system. So you're starting with a nice, fresh, pristine, secure tenancy to work with. I wanted to quickly talk about some of the just very core security stuff too, not to get super geeky, but one of the other things that we off-boxed was something called root of trust. So we created a custom security chip, this root of trust card, and this root of trust card has a couple of different components to it, a communications and security processor. The communications processor does a lot of the off-box virtualization that I was talking about before, like the smart NIC. But there's also a security processor piece of it. What this actually does is in first generation clouds, there was actually this attack that you could do where if you were getting certain servers, you could put malware on like a power supply or on different hardware components. So we wanted a way that we could off-box the reprovisioning of physical servers in a very secure way. So we created a custom off-box security root of trust chip. And anytime a server is reprovisioned from one tenancy to another tenancy, this goes through a completely offline, secure reboot and cleansing of everything on that physical device, including the power supply, all of the firmware. So everything is completely coming from a trusted root. via that custom security process. So kind of some like cool things that we've done internally, and this is how we get all of our certifications from a GovCloud perspective and others. And I won't go through this, but of course, I mean that we have attestations across all of the major certifications, and we continue to work very closely across regions and globally and with governments to make sure that OCI is the most secure place for your workloads. Last but not least, just from a storage perspective, we have a variety of different storage offerings. So as you're deploying a VM, so if you have an OpenVMS and it's running inside a VM container, then you want to use storage. Okay, so what are my options? So if you're deployed on bare metal, you can do local NVMe storage. If you're a VM, we're going to attach block storage, and you can start attaching different block storage devices, including boot devices and then block storage devices for your applications. We do have a file storage service. So if you need to just have a platform as a service, file service offering that can be shared across all of your different VM infrastructure, we have file storage services. And then we have our object storage, which is, you can think of this as your S3 bucket type of architecture. It actually is S3 compatible, but this is our more for documents, for files, unstructured data, archive storage. So a variety of different tiers for your applications as you're deploying them out there. And this gives you just kind of some snapshots on what you can expect from a performance perspective. And certainly as we start getting into our bare metal, this is where you can really get into, like if you're doing large HPC jobs and you need a tremendous amount of IOPS, you start looking at doing bare metal services versus VMs. We actually do have some really neat ways with some partner solutions to take a pool of VMs and treat them like a cluster, so you can get maximum IOPS across a pool of VMs for large types of streaming applications. So there's some cool things you can do to get to hundreds of thousands of IOPS even with VMs. And then I talked about it, our database services continue to be a very important part of Oracle, but it's not just Oracle databases. We have a variety of different database offerings. The Oracle database is a converged database, so you can do JSON, you can do relational, you can do graph, and you can now do vector as well. So you can bring all of the different database types into one Oracle converged database, which is very cool. But if you're using MySQL today and you want to continue to use MySQL, we have a great managed MySQL offering. And we have something called HeatWave, which allows you to do high performance analytics on top of MySQL transactional data. So a lot of really cool stuff that you can do from a data perspective. We will meet you where you are, including Oracle and non-Oracle databases. And non-relational data, of course, as well. And that just an example of what a lakehouse architecture would look like with a combination of Oracle object storage, as well as here we have our I'm saying either MySQL or autonomous, our different data integration options. So you can create a very modern data platform architecture, including all of the analytics with all of the Oracle components, but you could also be bringing in your third-party other components to use in here as well. Not so much a technical perspective, but we do have a pretty healthy marketplace, and we have customers. There are some folks. Oh, sorry, question.
Sorry, I have a quick question about how you handles backups when it comes to the storage and block volumes.
Yep.
And restoration of a VM when say crashes or something.
Yeah, great. Yeah, great question. So so we do backups. So there's kind of tiers of it. So first we do backups. So that tale of two customers that I talked about with Phoenix and what happened. So my one customer that was in just that one fault domain, and it was a block storage outage. So there was a top of rack failure, block storage outage. And we have replications for all of those block storage. So we're doing the replication on the back end on our tier, because we have to guarantee that if you put your data in, you're going to get your data back. So all of the data was restored, and we have SLAs for that as well. So we're doing that first tier. Now, as you do a deployment, like let's say that customer said like, hey, I'm gonna do a deployment. I have my VM in fault domain 1, and I'm gonna put my other VM in availability domain 2. So maybe they did 2 availability domains, and they have block storage here attached to this VM. You're gonna do block storage replication. So you can replicate that block storage now to another block storage. So you're kind of doing your own in-tenancy replication as you're doing your deployment. And then you could do cross-region replication as well. And that's more kind of real-time replication. You can then also do backups. When you're specifying your block storage, you can specify how you want those to be backed up. And if you want to do cross-region backup or local backups as well. So you have a bunch of options there. Then you get to like database. Database has its own backup options as well. So you could use RMAN, you could use DataGuard, you can use a whole host of different database options from a backup perspective. Object storage, we're doing the backup for you because object storage is really a PaaS service. It's a bucket. So we're responsible for kind of doing the resiliency of that object storage. Object storage, by the way, is an NFS based system. So we're kind of, that's behind the covers what we're doing. But then you can also do object storage to another region if you wanted it for high availability purposes. So I know that's a long answer, but there's a lot of different ways that you can do replication, and we're handling the core of it. But then within your tenancy, you can do your roll out your own stuff for high availability and scalability purposes. Yep, of course. Any other questions on storage? I'll very marketplace. We have a lot of partners that are deploying stuff. So if you're an ISV, you want to be on our marketplace, we'd love you to be there. And I love, advertising our ISVs. We actually, like a lot of times, I'll do co-events with them and tell our customers about the great stuff that's on our marketplace. I heard a couple of names earlier of customers that are on the OCI marketplace, like Commvault was one that the gentleman was mentioning here earlier. They're a big one of our customers on the marketplace. And last but not least, it is really inexpensive to run stuff inside OCI. And it's a reason why a lot of folks look at it at first, but then they start realizing why it's inexpensive. It's inexpensive because of all of the really cool engineering stuff that I talked about. The economics just kind of come out of that because of the way that you can design your architecture, because of the way we let you to flex those images and use just what you need from a memory or CPU perspective. So it's the engineering stuff that really matters, and that leads to some better economics for our customers as well. That's all I have from a presentation standpoint. I know we have about 10 minutes left, so I'm happy to take some questions, comments. Just out of curiosity, has anybody in the room used OCI? Are there any OCI? So, okay, so yeah, we have some good OCI. Are you VMS? So you're VMS, any non-VMS users, folks using OCI? So it is, I will say, like we've actually done a really cool job with the free tier of OCI too. I use free tier to run Minecraft servers for my 10-year-old and 12-year-old. There's actually a lot of stuff you can do with the OCI free tier. So I encourage you to check it out. There's some good stuff there. And then the team I lead, so I have about 100 engineers across the US that are only focused on helping our customers migrate into OCI. Traditionally, folks would think of it as like a pre-sales team, but there's no such thing as pre-sales and post-sales anymore in cloud. A lot of the work that my team does is actually once customers are already in OCI and they're expanding and they're using more. That's what we love doing. We love working with you and your workloads and trying stuff out. And also a good advantage of being fast followers. We're very eager to work with our customers and try out some cool things and move into OCI. All right. Well, thank you very much, everyone. I hope you enjoy the rest of your boot camp.